types of chemical reactions, there are 5 general types of chemical reactions. The first type is combination, where 2 or more substances form a new substance. So I'm going to produce one product in a combination reaction. Number 1, if I have a group A metal, like potassium, reacting with a nonmetal, like chlorine, the product is a compound consisting of the ions. So potassium bonds to chloride, and we do the charges, +1, -1. So KCl is my product. And then I can go back and balance this with coefficients. So 2 elements produce one compound. Number 2, when 2 nonmetals react, such as nitrogen and oxygen, more than one product is often possible. However, for our purposes, we're going to use the most common charges, oxygen being a -2 and nitrogen being a +5 in this case. So N2O5. And then we can go back and balance this equation with coefficients. Again, 2 elements produce one product. Number 3, in a combination reaction of a transition metal, like copper, plus a nonmetal, you can have more than one product, but we're going to use the most common oxidation state. Copper is in group 1b, charge of +1. Sulfur, -2. So Cu2S would be the product here. So combination reactions for our purposes, 2 elements combine to produce one product. Decomposition reactions, exactly opposite of combination. We're going to look at binary compounds. These are rather easy to predict. So for example, water will decompose to produce the elements that make it up, which are H2 plus O2. They're both diatomic when they're by themselves. Normally these reactions require energy in the form of heat, light, or electricity. Say, for example, we have HI. That will decompose into its elements, which are H2 and I2. But again, these require some kind of catalyst to make them happen. So binary compounds, rather easy to predict the products. They produce the elements. Single replacement reactions. You have an element reacting with a compound. In this type of reaction, we have to look at what's known as the activity series for metals. Metals will only replace other metals if they are more active. Lithium is the most active metal, and it goes down to silver as the least active metal. I'll give you some examples. Let's say we have iron reacting with lead nitrate. So you have an element plus a compound. Now whether these will happen, you have to go back to the activity series, compare iron to lead, find iron, find lead. Iron is more active, so it will switch. So iron will now combine with NO3, and lead will be by itself. Iron will replace lead, a single replacement. Let's say we have calcium reacting with water. Calcium and hydrogen are both positive. Go back to the activity series. Here's calcium up here. Here's hydrogen. Calcium is more active, so it will switch with hydrogen. So calcium, positive, combines with oxygen, which is -2, and then hydrogen will be by itself, which is H2. It's diatomic by itself. Look at one more example, CaCl2 plus magnesium. Okay, again, compare activities. This time, calcium and magnesium. Here's calcium, here's magnesium. Well, magnesium is less active than calcium, so magnesium will not switch. No reaction will take place. So it is possible to get nothing happening with a single replacement. There's also a halogen activity series. Halogens are group 7A, fluorine, chlorine, bromine, iodine. The activity decreases as you go down 7A, so fluorine is the most active halogen, and then chlorine, then bromine, and so forth. Give you a couple examples of some halogen single replacement reactions. Cl2 plus NaI. Whether chlorine will replace iodine, you go back to the activity series. Chlorine is higher in activity than I, so yes, it will switch. So sodium combines with Cl. Sodium is positive, Cl is negative. Iodine will be by itself, and that's diatomic, I2. And then you can go back and balance. Let's say we have Br2 plus sodium chloride. Well, I'm going to compare bromine to chlorine. Activity series, bromine is less active than chlorine, so it will not switch. No reaction occurs because bromine is less active. So single replacement reactions, element plus a compound. Double replacement reactions, two compounds react. Something has to drive these reactions. Number one, a driver of the reactions is you form a precipitate. For example, let's say we have Na2S reacting with cadmium nitrate. With double replacement reactions, I'm going to put the charges over here. What's going to happen is the positives are going to switch, so sodium combines with NO3, and that's a +1, -1, so that's my product. I don't necessarily carry those subscripts from side to side. And the other product is cadmium, which is a +2, with sulfide, which is a -2. So there are my products. Now what drives this reaction is the formation of a precipitate, which is cadmium sulfide. Another driver of these double replacements is the production of a gas. Let's say I have NaCN reacting with H2SO4. Two compounds. I'm going to put the charges over here because the positives are going to switch. So sodium combines with SO4 to give me Na2SO4 because of the charges. Hydrogen combines with cyanide to give me HCN. HCN is a gas, and that's what drives this reaction forward. And then I can go back and add coefficients. Then finally, the other driver is you produce a compound such as water. So for example, calcium hydroxide reacts with HCl, charges +2, -1, +1, -1. So you're going to get calcium chloride plus HOH, which is water. That's a liquid, and that drives the reaction forward. And then you can go back and balance. So a double replacement reaction, two compounds react every time, and the positives switch places. Fifth type of reaction is a combustion reaction. Combustion is the reaction of a compound with oxygen. For example, C6H6 reacting with oxygen. Combustion of a hydrocarbon produces carbon dioxide and water every single time. So combustion of C6H6 would produce carbon dioxide and water. To try to balance this, if you try a 6 here to balance the carbon and a 3 here to balance the hydrogen, you'll notice that with oxygen, there's 12 oxygen here, but only 3 oxygen here. That's an odd number. It has to be an even number because it's O2. If you run into this problem, double the coefficients. Make this a 2. Make this a 12. 3 becomes 6. And then I can balance oxygen. I have 24 here, plus another 6 here. That's 30 oxygen. So I would need 15 O2. let's say I want to combust C6H12O6, reacting with oxygen. But again, combustion produces carbon dioxide and water every single time. And then you can go back and you can add coefficients to balance. So you have 5 general types of reactions: combination, decomposition, single replacement, double replacement, and combustion.